Let's discuss how to do some work rate problems. If a job can be done in T units of time, then the rate of work, R, is the reciprocal 1 over T of the job per unit time. So we have the rate is equal to 1 divided by the time. For example, if I can complete a job in 3 hours, well, that means I do 1/3 of the job every hour. The amount of work completed A is found by multiplying the rate of work R and the amount of time worked T. This formula is similar to the distance formula D equals R times T. The amount of work completed is equal to the rate of work times the amount of time worked, or A equals R times T. The amount of work is equal to the rate of work times the amount of time worked. So let's try an example with work rate. One printer can do a job twice as fast as another. Working together, both the printers can do the job in 2 hours. How long would it take each printer, working alone, to do the job? We've read the problem. We must find the time it would take each printer working alone to do the job. In example 3, the best way to do it is to construct a table. Now there's two types of printers. We have the fast printer and we have the slow printer. Now I don't know how long it takes for the fast printer to do the job by itself, so we're going to give that name an X. That's going to be the time it takes the fast printer to do the job. Now the slow printer is going to take twice as long, so this would be 2x. This takes twice as long, so that's why we have 2x for the time. Now the rate, remember the rate is just the reciprocal, or 1 over x of the time. Same thing here for the slow printer, we know that's 1 over 2x, the reciprocal of the time. Now, in the problem it says it takes 2 hours for both of them to complete the job together. So we'll put 2 hours for the time. Now each table is going to be different, so you'll have to read it, and certain things might change, but not much. The table is very useful to organize the information. Now recall the formula, A is equal to R times T. So I know the amount of work completed is the rate times the time. So let's multiply 1 over x times 2. That's going to be equal to 2 over x. And now we're going to multiply 1 over 2x times 2. And if you simplify that, that's going to just give us 1 over x. Now this is the amount of work completed by the fast printer, and this is the amount of work completed by the slow printer. In step 3, we're going to write an equation. The sum of the two parts of the job accomplished is 1, since one whole job is done. We have the work done by the faster printer is 2 over x, and the work done by the slower printer is 1 over x. And this has to be equal to 1, because we're completing one job. In step 4, we need to solve the equation we just created. We have 2 over x plus 1 over x equals 1. Now what's our LCD? Our LCD is going to be pieces of the denominator. I need an x. I don't need this x because we already have it in our LCD. And that's it. So all we need to do is multiply every term by x. We'll multiply x times 2 over x times 1 over x, and x times 1. Again, the red part is our LCD, and the black part is our original equation. Let's see what cancels out. We have x disappears, and now we can simplify. I have 2 here, plus 1 equals x.
And of course 2 plus 1 is 3, so x equals 3. Let's state the answer. The faster printer would take 3 hours to do the job alone, and the slower printer would take 2 times 3, or 6 hours. Be sure to give both answers here. Remember, we have 3 hours for the faster printer, and 6 hours for the slower printer. In step 6, we'll check our answer. The answer is reasonable since the time working together, 2 hours, is less than the time it would take the faster computer working alone, 3 hours.
The power property. If P and Q are algebraic expressions, then every solution of the equation P equals Q is also a solution of the equation P to the n equals Q to the n for any positive integer n. What the power property states is if we have P equals Q, then I can raise both sides to a positive integer and we would still get the same solution. To solve an equation involving radicals, there are 4 steps. Step 1, isolate the radical on one side of the equation. Step 2, raise each side of the equation to a power that is the same as the index of the radical so that the radical is eliminated. If the equation still contains a radical, repeat step 1 and 2. Step 3, solve the resulting equation. Step 4, check each proposed solution in the original equation, making sure it works. Example 4, let's solve x minus the square root of 15 minus 2x equals 0. The first step is to isolate that radical, so let's add the square root of 15 minus 2x to both sides. I want to isolate that radical. This gives me x equals the square root of 15 minus 2x. Now what I could do next is raise both sides to a power of 2. And that's going to cancel out that radical on the right side. This gives us x squared equals 15 minus 2x. Now I could solve this by setting this quadratic equal to 0. So let's add 2x to both sides. And let's subtract 15 to both sides. This gives us x squared plus 2x minus 15 equals to 0. And now we can try to factor this. I can factor this using the diamond method. We have negative 15 and 2. The two numbers are 5 and negative 3. And so this factors as x plus 5 times x minus 3 equals 0. I can set each of the factors equal to 0. And then we can solve for x. So for the first one, we'll have to subtract 5 to both sides. And for the second, we'll have to add 3 to both sides. So we have two possible solutions. X equals negative 5 is one, or x equals positive 3 is another. But remember, you have to check to make sure these solutions work by plugging them into the original equation. So I'm just going to quickly check here. Let's plug in a negative 5 first to make sure that works. We are replacing this x with negative 5. So I have negative 5 minus the square root. 15 minus 2 times negative 5 is that 0. That's negative 5 minus the square root. This is a plus 10, this is a 25, and is that 0? We have negative 5 minus 5, that's not equal to 0, that's not true. So we're going to throw out this solution. X equals negative 5 does not work, it fails. Let's check 3 now. Let's check x equals positive 3 now. I have 3 minus the square root of 15 minus 2 times 3 equals 0. We have 3 minus the square root. 15 minus 6, Well, that's 9. And then we know the square root of 9 is just 3. 3 minus 3 is indeed 0, so this works. So we only have one good solution, x equals 3. In example 5, I'm going to isolate the radical, but since there's two radicals, I could decide to move the square root of 2x plus 3 or the square root of x plus 1. Let's just move the square root of x plus 1. The reason I'm choosing to move this to the right is because it makes it a positive radical, which is a little bit easier to deal with. So let's add the square root of x plus 1 to both sides. And this simplifies to the square root of 2x plus 3 equals 1 plus the square root of x plus 1. Now I could raise both sides to a power of 2. This is going to cancel out this radical. It's going to give me 2x plus 3. Now what's going to happen here? We're going to have to FOIL. This is going to become 1 plus the square root of x plus 1 times another 1 plus the square root of x plus 1. You have to FOIL. So let's simplify that by FOILing. 1 times 1 is 1. 1 times the square root of x plus 1 is square root of x plus 1. This is again the square root of x plus 1. The square root of x plus 1 times the square root of x plus 1 is x plus 1. The radical just cancels out. So let's collect like terms now. We have 2x plus 3 equals, I have the 1 and the 1 can be added together, that's 2. The square root of x plus 1 and the square root of x plus 1, that's 2 square root of x plus 1. And then we have an x here we'll bring down. There's still a radical here, so let's try to isolate that. I'm going to subtract x to both sides, and I'm going to subtract 2 to both sides. So you can see that 2 and negative 2 cancels out, and x and negative x cancels out. We have x plus 1 equals 2 root x plus 1. So remember, we have to square both sides. We have x plus 1 squared is equal to 2 times the square root of x plus 1 squared. And we're just trying to cancel out that radical. So that's why we raise both sides to a power of 2. On the left side, I have to FOIL. So we'll have x plus 1 squared is going to have to be FOILed. So on the left, we'll FOIL x plus 1 squared. That's x plus 1 times another x plus 1. On the right, we can distribute this 2 to the 4. That makes that a 4. And the x plus 1, that's going to cancel out that radical when you square it. So we'll just have 4 times x plus 1. Now let's FOIL the left side first. We have to FOIL. So I have x squared plus x plus x plus 1 equals 4 times x plus 1. Let's collect like terms. X squared plus 2x plus 1 equals 4 times x plus 1. So now we can distribute that 4. This gives us x squared plus 2x plus 1 equals 4x plus 4. Let's subtract 4x to both sides, and we'll also subtract 4 to both sides. This cancels and this cancels. I have x squared minus 2x minus 3 is equal to 0. And let's see if we can factor this. We have negative 3, negative 2, and so the numbers are negative 3 and positive 1. X minus 3 times x plus 1 equals to 0. I can set both of those equal to 0. And so you can see our two possible solutions are x equals 3 or x equals negative 1. But remember, you got to check this in the original equation to make sure it works. So I'm going to check this individually. Let's check the 3 first. We'll plug in the 3 for the x. 2 times 3 plus 3 in the square root minus the square root of 3 plus 1. Is that equal to 1? 2 times 3 is 6 plus 3, that's 9. Square root of 9 minus the square root of 4, is that equal to 1? Yes, it is. So this is a good solution. Let's check the other one. 2 times negative 1 plus 3 minus negative 1 plus 1, is that equal to 1? 2 times negative 1 plus 3, that is 1. The square root of 1 minus the square root of 0, is that equal to 1? Yes, it is. The square root of 1 is equal to 1. So they're both good solutions. X equals 3 is a good solution, and x equals negative 1 is a good solution. In example 6, again, my idea is to always isolate the radicals. Since there's 2 of them, we'll try to isolate both of them on each side. So let's add the cube root of x to both sides. This gives me the cube root of 4x squared minus 4x plus 1 equals the cube root of x. Now we're going to raise both sides to the third power because we're trying to cancel out a cube root. If it's a square root, we'll use the power of 2. Since it's a cube root, we'll use a power of 3. So what happens is we get 4x squared minus 4x plus 1 is now equal to x. Let's subtract x to both sides. That results in 4x squared minus 5x plus 1 equals 0. Now this is going to use the AC method because we have a leading coefficient. So let's multiply 4 times 1, that's 4. And let's try to factor this if possible. The two numbers that multiply to get 4 but add up to negative 5 are negative 4 and negative 1. And remember, since we have a leading coefficient, I better make sure I split the middle as negative 4x and negative 1x. Now we can do factor by grouping. Let's check for the groups of 2 here. I can factor out a 4x. So we'll take out 4x. What's left is x minus 1. Here I can factor out a negative 1. And then we get x minus 1 left over. And yes, these are the same, so I know I did it right. We'll take out x minus 1, and what's left is 4x minus 1. So we're just factoring the left side, and now we could set each one of these equal to 0. So x equals positive 1 is one possible solution, and if you solve this one, you get x equals 1/4. Now we're not done yet. You have to check in the original equation that these two solutions are good. So plug in a 1 into the x, and you should get a 0. I know that this solution is good, so make sure you double check, plug it in, make sure you do get a 0. Plug in the 1/4, plug it into this expression, and you should also get a 0. Both these solutions are good, but it's up to you to check the work, so please check the work on your own.